Hello and welcome to Lab 5. So today we are going to cover MLOps, and this is where everything comes together. So in day 3, in Lab 3 and Lab 4, we trained a churn prediction model and deployed it manually. So today we're going to automate the entire process using SageMaker Pipelines. And then you're going to monitor our deployed model using CloudWatch and talk about data drift. So by the end of the session, I'd like you to understand how production ML systems are built, not just training a model once, but building a repeatable automated pipeline that preprocesses data, trains, evaluates, and is ready to deploy. So before I write any code, let me just explain what SageMaker Pipelines actually is, because this is a concept that comes up heavily. SageMaker Pipeline is a DAG, so directed acyclic graph of steps, and each step is a managed job that SageMaker runs on its own compute. So the steps are connected, meaning the output of one step automatically becomes the input of the next. You define the pipeline once and you can run it as many times as you want on new data, on a schedule, or triggered by an event. And this is the foundation of machine learning ops. Instead of a data scientist running cells in a notebook manually, you have a reproducible, auditable, automated workflow. So our pipeline today has 3 steps. The first step is processing step, whereby it's going to clean and split the data. And then we do have the training step, so where it's going to train our XGBoost model. And then the evaluation step, where it's going to score the model on test data and write the metrics to S3. Just to get started as well, the first step, just getting our data ready. So the session setup. Of course, we'll start by S3 and uploading our data. So back to my bucket. So still same bucket. And now I can create a folder called MLOps lab, and then we'll have where we put our data. So create folder MLOps lab. So we can have inside it a folder called data. And then you go ahead and upload our file. So I'm going to add file. And yep, that is the first step. Of course, the next step is to go back to SageMaker. So under SageMaker AI, you open SageMaker Studio as usual. Open the studio, which will take us to this specific place, home. And you go ahead and open your compute basically, and it will take you to this specific page. And you can go ahead and create a Python 3 notebook as well and name it as you wish. So here I have my notebook. So it's called the Day 5 MLOps pipeline. And let's take a look at what is happening over here. So first things first, the context and the setup session. Okay. So as you can see, we have the SageMaker session over here, step 1. And it's going to create a session object that knows which account and region we are in. It handles all the communication between our notebook and the SageMaker service. And then we do have the get execution role that retrieves the IAM role attached to this SageMaker Studio environment. So this is the role that gives SageMaker permission to read from S3, create training jobs, create processing jobs, and write the output back to S3. Okay, so we are using the same bucket, ML Labs Chan demo, but under a new prefix, the MLOps lab that we created as well. So basically it, and then the second cell, verify data in S3. Before building the pipeline, we verify that the data set is actually in S3. So this is good practice. You never want to kick off a 20-minute pipeline, run only to find that the input file is missing. So this is what is happening over here. Yeah, just to verify. So head object is a lightweight check. It does not download file. It just asks S3, does this file exist? What are its properties? And if the file is missing, it's going to throw an error immediately, and we know to fix it before going further. So our data set is the day 5 MLOps dataset, which consists of 200 rows of customer churn data. And I can show you the dataset. So let me see. That is the customer age, the tenure, charges, total charges. So wait, I don't think this is the correct dataset. Okay, let me find the correct one. This is how our MLOps dataset looks like. Just going back. And checking our code. So this is what is happening over here, just the same steps. And when you run this cell, basically, you get all the information on the role, the region, and the packet. Okay. So the next part is the pre-processing script. So there is something important to understand about SageMaker processing jobs. When SageMaker runs a processing job, it spins up a completely fresh container, a brand new machine in the cloud. And that machine has no idea what our notebook looks like. We have to give it a Python script to run. And that script is the preprocessing .py script that we have available. Let me just show you what it looks like. So you'll basically go ahead, just create a Python file, or not a notebook, but a file. So it will be this, and you'll copy the code that is available here. So you'll just name it preprocessing .py as well. So what you can see over here, the first things are the paths. So these paths are fixed by SageMaker. When the processing job starts, SageMaker will automatically download our file and place it here in this input path. So keeping the original file name, that's why it's as it is. And then our script is going to read from there. When the script finishes, SageMaker takes everything in the output basically, so here, and uploads it back to S3. So we never have to write S3 code inside the script itself. SageMaker is the one which is going to handle the data movement for us. The next thing, we drop the customer ID because it's just an identifier. It has no predictive value. If left in, the model might accidentally learn patterns from ID numbers, which could be meaningless. What else? So encoding, XGBoost requires all inputs to be numeric, and we have these two columns that are categorical strings. So we encode them as integers. The ordering is intentional. A month to month gets 0 because it is the highest risk. And then 2 years get 2 because it's the lowest risk. So this ordinal encoding helps the model understand the relationship between contact types. And then we have here, so this reorders the columns. So churn is first, and this is a requirement of SageMaker built-in XGBoost algorithm. It expects the target variable in the first column with no header. And the next part, so training and so on. So what we're doing over here, we're doing some split. Okay, so let me scroll down. We split 80% of training, 20% for testing. So you can see test size is 0.2 over here. So random state equal 42 makes the split reproducible. So every time we run this pipeline, we get the same split. So which is important for comparing result across all runs. So no header, no index. Again, XGBoost built-in requirement for that. It expects that as well. So this is the pre-processing file. And now back into our notebook. So after we have created this file, now we are going to define the processing step that is going to happen in this case. So first things first, we need a container image that has scikit-learn installed, because our pre-processing script uses pandas. Yeah, so you can see over here, it uses pandas and the scikit-learn to give us the official AWS managed container URI for our region. So we don't build or maintain that container image, AWS provides it. So over here, we can see the processor. So script processor is the SageMaker class for running a custom Python script in a managed container. So we tell it which image is going to use. We want to run Python 3 and which instance type to use. So make sure this instance type is something that you have available in your account. So go check your service quotas before selecting this specific instance, just to show you how. So under the service quotas, we do have SageMaker. And we are interested for processing. Okay, so you can see a lot of these instances on my end, I don't have access to them, but I do have access to these specific instance types for processing. So if you select any other and you have 0 quota, it's going to fail, okay? So for me, I have access to MLT3 large for processing, and that's why I selected it to be used. So be keen on that, okay? Which instance type? So this one is a general purpose instance. It's cost effective and it's perfectly adequate for data processing. And then we have we do have the input data URI, where to get the input, and the output base as well. We have the processing step over here with the outputs. So this is just a definition. Basically, nothing runs yet. We are telling SageMaker, when this step executes, take the file from S3, put it at input path, and then go ahead and run preprocessing.py, basically our file, and upload whatever ends up in the output back to S. That is basically what is happening over here. You can see we specified where the code is, and we specified where to put the output. So train and test, basically. So that is the part on the data pre-processing as well. We now move into the training step. So the model training, and the training step is going to use the XGBoost built-in algorithm as well. Let me take a look at the code directly. So here it is. Okay, so let's say some of the things to look at. So we have the binary logistic. This means that you're doing binary classification, and the output will be a probability between 0 and 1. A num round is the number of boosting rounds. 100 is a good starting point. ETA is the learning rate. So 0.2 means each tree contributes 20% of its weight, which prevents overfitting. We do have the subsample of 0.8, means each tree only sees 80% of the training data, again, to prevent overfitting. And then this is the key part, the training step. So let's see. Over here, properties, oopsies, processing output config. So we are not hard coding an S3 path. We're just saying like use whatever S3 path the pre-processing step wrote the train data to. So SageMaker is going to resolve this at runtime. And this is what makes the pipeline dynamic and reusable. If the pre-processing step writes to a different location next time, the training step automatically picks it up. So that is the training step. And now, remember we had 3 steps. Now the evaluation step runs after training. It's going to take the trained model artifact and the test data, run predictions, and then write the JSON metrics back to S3. So as you can see over here, as the code is, you can see again inputs are, the pipeline properties. So the model artifact from the training step and the test data from the pre-processing step. So again, none is hard-coded. So let me show the evaluate as well quickly. So here it is. So just to summarize what the script does, it's going to extract the model. You can see the model path. So it's going to extract the model, load it with the XGBoost, run predictions on the test set, compute accuracy, precision, recall. So you can see these metrics that we have defined. And then it's going to write back a structured JSON report. So that JSON is what we are going to read at the end to see our metrics. So that is it. And then the final step is to assemble our pipeline. So our pipeline equal to pipeline, whatever. So the pipeline is going to take a name and a list of steps. So the name will be this, and the list of steps is process, train, evaluate. So the order matters. So SageMaker infers the dependency graph from how these steps reference each other's properties. So since training references pre-processing output, SageMaker knows pre-processing must run first. What else? We do have upsert. So upsert registers or updates the pipeline definition in SageMaker. So just think of it like deploying a CloudFormation template. So it stores the pipeline definition. So you can run it, schedule it, versioning as well. And then pipeline.start kicks off an execution. And this is when the actual compute starts. So when you run this cell, so you'll get pipeline registered, pipeline started, and you get the pipeline Amazon resource name. So let me go to SageMaker. So if you go back to this specific page, SageMaker Studio, at the very bottom, you can see pipelines. And this takes like some minutes as well. So you can see the latest pipeline I ran that succeeded. It's important that, so the reason why all this failed, if I just show you. So let's see. So again, the service limit, okay? So if you don't have such an instance, it's going to fail. So I had to figure out which instances are available to me. So just make sure at each step back in here, let's say. So at the processing step, choose, go to your, your quarters. You can choose for processing and see any that you have available. So for me, only these 3 would work. And then the next one is for the training step. So search for training. And unfortunately, I don't know why mine is not responding as well. But yeah, I advise you go with ML large. Let me check which I used. So for processing is T3 large. For training, MEL M5 large is what worked out for me. And then for evaluation, it still uses the processing one. So ML T3 large. So all these failures were just because of the service limits. Oh, okay. So back to my pipeline. Now looking at one that was successful. So this process takes like a good, you can see for a successful one, took like a good 13 minutes, okay? Yeah, and you're going to see how it moves from pre-processing to training to evaluation. Pre-processing will run fast. You will see it spinning once it completes. The training starts immediately, automatically. Then evaluation. So this is what MLOps looks like in practice. A data engineer or an ML engineer defines this pipeline, and then it can be triggered automatically on a schedule, maybe when new data arrives in S3 or via CI/CD system. So no human will need to go and manually run the notebook cells. 3 steps are now green. That means that the pipeline completed successfully. So next step is now to evaluate the metrics. So back over here. So we were here, and now we try evaluate the metrics. So here's the code, and we want to evaluate metrics based on accuracy, precision, recall, and F1 score. So you can see these are the evaluation results that you're getting, and they're excellent. Yeah, so accuracy, just a reminder, it just means the model correctly classified 97% of our customers. Precision means that, every customer the model flagged as churning actually did churn. So we had 0 false positive. Recall, 94% means we caught 94% of actual churners. And then F1, 97%, 0.971 is the harmonic mean of precision and recall. So a single number that balances both. So again, in real business context, recall is often more important than precision for churn prediction, because missing a churner, like a false negative, means losing a customer. But falsely flagging someone that is a false positive just means sending them a retention offer they didn't need. So high recall is what you want. And now that is the first part. And now we can go ahead and, move to the second part, which is monitoring a deployed endpoint. So after checking that and we think, okay, everything looks good in this case. So we are going to go ahead and deploy. So get the model artifact from the training output. So we get that model artifact and then we deploy the model. So some keywords like estimator attach. So it just reconnects to an already completed training job by name. So we get the training job name from the pipeline execution, and then deploy creates a real-time inference endpoints. So we use a fixed endpoint name, in our case, Chan MLOps Lab 5, because I just want to make it easy for me to reference the endpoint in monitoring. So this also takes a while, like I'd say a good 4 or 5 minutes. And you can go to SageMaker as well, and you go to endpoints, and here it is. And it will be in creating status, and after a while, it's going to get in service as well. So that is it. And now you can go ahead and test it. So here's just a sample code with some test cases with it. So here are the test cases. So the payload is just a CSV that we have available, and we're just trying to test, and you are getting some probability. So here we got like the probability of 0.985, and it's just the sample that we used before. A customer who is 28 years old with only 3 months tenure, high monthly charges as well for month-to-month contract, using fiber internet. So every single risk factor is present. So this is just the exact pattern that you are expecting. So the contract type and tenure are the dominant features in our data set. So that looks good. And now we can go ahead and after we, send that, you can go ahead and to CloudWatch and see what basically is happening within our endpoint. So you can go to CloudWatch. So just search CloudWatch, and then you can go ahead and check the metrics. So let me refresh. So under SageMaker, you can just search for SageMaker and then endpoint metrics. And you can check which metrics you'd like to look at. So maybe the invocations, the 500 errors, model latency as well. And then you'll have your graph over there. You can choose however you want to view this information as well. I can say maybe I want to check this, maybe past 1 hour. Let's see. So we do have some information that is present. So after a while, you're going to get better views than this. So you can wait like, 3 to 5 minutes and see some of the metrics that are available for such an instance. So let me see if I refresh, I'll see anything as well. Okay, I don't need all this. So maybe the first 3, and you can get a graph. And see, for example, the model latency at this specific point in time, the number of invocations. So I had 0 errors as well, but that is how you're going to review. So invocations is just steady count of requests coming in. Model latency, the time in microseconds, the model takes to generate a prediction. And then invocations, 500 errors, they were 0. So no server errors. In production, you might want to go ahead and set CloudWatch alarms on these metrics. For example, let's say the model latency exceeds a specific amount. You can just go ahead and create an alarm. So something like, let's see which number. So the model latency on an average of 5 minutes is, exceeds like 500. In that case, you can just go ahead and goes in an alarm, set notifications, or do whatever you want to do as well. And then last concept for today's data drift. So when we trained our model, so let me go back. And I also have like a sample code that you can use to just generate some traffic to CloudWatch, so you can see something as well, but you have to wait a little bit because they aggregate within 5-minute intervals to see the results as well. So this is it. Now, in terms of drift, when we trained our model, 55% of our customers were, month-to-month contracts. So imagine 6 months later, the business runs a promotion and converts many customers to 2-year contracts. Now, only 20% are on month-to-month. So the model was trained on a world where month-to-month was dominant. It has never seen a world where 2-year contracts dominate. Its predictions may become unreliable, not because the model is broken, but because the world changed. And that is what data drift is about. So the statistical distribution of incoming data has shifted away from training distribution. So the action is clear, basically. So in that case, you have to train the pipeline with new data that reflects the current distribution. And this is exactly why we built a pipeline. Instead of a one-off training job, we can rerun the entire pipeline with new data in one command. Just, do a pipeline start again. So that's it. New data in S3, same pipeline, but a fresh model is available. So that is with data drift as well. Let me see if I missed something. We have basically gone through the steps, evaluation of the model. You go ahead, the step to run the pipeline. We saw what the pipeline looked like as well. Then we saw the evaluation results. Yeah. And we deployed the model. I mentioned about the instance configurations. Be careful on that as well. And we're able to make predictions and view some metrics as well. So if this was production-based workload, we would have better graphs. Maybe they'd look something like this as well. You can create alarms, for example, if there is high latency or high error rate for server errors, you can create an alarm to get notifications for that as well. We have discussed data drift, and the remediation for that is, in case there is a significant drift, maybe you go ahead and retrain the model. So that is it. And yeah, always remember to clean up your endpoint. When you are done, here's the code. So just go ahead and delete the endpoint. The pipeline definition stays in SageMaker, that's free. The model artifact stays in S3, that's a few cents a month, but the endpoint itself is going to cost some money. So a recap, we built a 3-step SageMaker pipeline, training with XGBoost, evaluating with custom metrics. The pipeline ran end-to-end and produced a model. And then we deployed the model to a real-time endpoint, generated traffic, monitored it with CloudWatch, and discussed data drift. What was it, how to detect it, and what to do about it. So that's a wrap, and thank you for following along.